Hello guys, welcome back to StudyMate. To be ready to unlock your true potential. Today we have physics class with Ismail Mirza Inayat, and so we will start. Today we will learn about the speed in AS and A level book. So it's also useful for IGCSE students. So we will use this site for learning. The speed of an object is the distance it travels per unit time. So speed is scalar quantity because it only contains a magnitude without direction. But velocity is another thing because it is speed with direction. So it's not scalar, it's vector quantity. For objects that are moving with a constant speed, use this equation below to calculate the speed, distance traveled over time taken. So we have distance traveled is calculated in meters, and the time taken is in seconds, and speed will be in meter over seconds. So as you can see, a hiker might have an average speed of 2 meter per second, whereas the particular bumblebee can have average of 4.5 meter per seconds. So average speed. To calculate the average speed, we will sum up all the distance traveled and divide it by the all the time taken. So this will be average speed. So as you can see here, this graph shows the total distance, average speed, and time taken, because total distance is equal to average speed times time taken. How to use formula triangles? So as you to use this formula, total time will be equal to average speed multiplied by time taken, and time taken will be equal to total distance over average speed, and average speed will be equal to total distance over time taken. So as you can see, you can use your hands to remember it easily. Worked example, and list the known quantities. We have the average speed 250 meters per square and time taken 2 hours. We should calculate the average speed. We should calculate the distance traveled. So to calculate the total distance, we will multiply this value by 7,200 seconds, because 2 hours is in hours. So but in average speed we are using seconds, so we should first convert this hour to seconds. So we will multiply it by 62 times, and it's equal to 7,200. So if we multiply both of them, it will be 1,800,000. So velocity, as I mentioned before, velocity is a speed with direction. So it's a speed of an object was scalar quantity, and velocity is vector quantity. It describes both magnitude and direction. Speed is 20 meters per second, and velocity is 20 meters per second east. In this same for this, but it's for west. So as you can see, velocity also uses the same formula. So we will move on to the next concept. So as you can see here, acceleration is the rate of change in velocity. It can be negative or positive. For example, if our speed is increasing over time, our acceleration is positive. So its acceleration is divided into two types: acceleration itself and deceleration. So in other words, it describes how much an object's velocity changes every second. So its formula will be change in velocity over change in time. So acceleration's quantity will be meter over meter per square second square. So change in velocity will be the final velocity minus initial velocity. So as you can see, we can use the same type of graph for this formula also. We will use our hands to find the formulas. For example, A is equal to V over T. So speeding up and slowing down. An object that speeds up is accelerating, and that slows down is decelerating. The acceleration of an object can be positive or negative depending on whether it's speeding up or slowing down. So as you can see here, the car has the acceleration of minus 5 meter per square second square, so it's called deceleration. The car is decelerating and the rocket is speeding up, so that's why it's accelerating with 30 meters per square second square. So we have the problem. Initial velocity is 15 meters per square and final velocity meters per second, and final velocity is 42 meters per second. So we should find the change in velocity. Change in velocity will be minus 8 meters per second. So now we have change in velocity and time taken. Time taken is 30 seconds, so it will be very easy to find A, or if you can't remember, we can use your hands to find A. V over T. So minus 8 over 30 is equal to minus 0.27 meters per second. So answer is negative, which indicates that train is slowing down. I think there is some mistake in the side. It should be meter per second square. So distance time graphs. Distance time graphs can help us to easily learn very difficult concepts. We will see it in this video. A distance time graph shows the how distance of an object moving straight line from position varies over time. For example, if distance over time, gradient of the function, I mean distance over time is v, velocity. So constant speed on a distance. This graph shows the constant speed of distance because it is linear equation, so we can see it is distance the constant speed. So if the graph looks like this red line, that means there is no movement.
Certainly.
The steeper the slope means the larger the speed. For example, as you can see here, this line has a very low speed because if you calculate the overall distance over the time, it's very low, and the if you calculate this red line, it has a really high speed compared to this line. So if we, for example, it's approximately 2, and if we have 2 and for example 10 distance, our velocity will be 5, and in here, as you can see, it's about 3 meters, and the time is about 10 seconds and 0.3 meters per second. So this is really a low velocity compared to the steeper one. So shallower the slope means the smaller the speed. Changing speed on a distance time graph. Objects might be moving at a changing speed. This is represented by a curve. So as you can see here, this curve decreasing slope means decreasing speed, and increasing slope means increasing speed. So as you can see, in this case the slope of line will be changing. If the slope is increasing, the speed is increasing. If the slope is decreasing, it's decelerating. So changing speeds are represented by changing slopes. So they are proportional. As you can see, if one increases, another is also increasing, and it's acceleration. So using distance time graphs, the speed of a moving object can be calculated from the gradient of the line on a speed time graph. So as I mentioned before, you can calculate the speed by rise over run. So gradient of this function is equal to speed, or in other words, it's change in y over change in x. The rise in change in y values, the run is change in x values. So worked example, distance time graph is drawn below for path of train journey. the train is traveling at a constant speed. So calculate the speed for the train. So to calculate the speed, we have kilometers